we want to solve the given trig equation tan squared x equals 4 sine squared x over the given interval. We will solve this equation by using a reciprocal identity for tangent x, where tangent x is equal to sine x divided by cosine x, and therefore tan squared x is equal to the square of sine x divided by cosine x. Let's also set the right side of the equation equal to 0 by subtracting 4 sine squared x from both sides of the equation, which gives us minus 4 sine squared x. Let's write this as a fraction with the denominator of 1, and this is equal to 0. And now simplifying, the square of sine x divided by cosine x is equal to sine squared x divided by cosine squared x. Now we want to subtract the fractions, and therefore we'll have to obtain a common denominator, which is cosine squared x. So we'll multiply the numerator and denominator of the second fraction by cosine squared x. So we have minus 4 sine squared x over 1. Then again, we multiply the numerator and denominator by cosine squared x to obtain a common denominator. And this is still equal to 0. Notice now we have a common denominator of cosine squared x. And the numerator is sine squared x minus 4 sine squared x cosine squared x. And again, this is still equal to 0. From here, a fraction is equal to 0 when the numerator is equal to 0 and the denominator is non-zero. And therefore, the fraction on the left is equal to 0 when the numerator of sine squared x minus 4 sine squared x cosine squared x is equal to 0, and cosine squared x can't equal 0. To solve this equation, we will factor out the greatest common factor, which in this case is sine squared x. If we factor out sine squared x, we have sine squared x times the quantity 1 minus 4 cosine squared x. From here, notice how we have two factors, and therefore the product on the left is equal to 0 when sine squared x is equal to 0, or 1 minus 4 cosine squared x is equal to 0. Let's continue on the next slide. For the first equation, to undo the squaring and solve for sine x, we take the square root of both sides of the equation. Remember, when square rooting both sides of the equation, we include a plus or minus on the right to make sure we get all of the solutions to the equation. The square root of sine squared x is equal to sine x, and plus or minus the square root of 0 is just 0. And now for the second equation, we first solve for cosine squared x by subtracting 1 on both sides and then dividing by negative 4, which gives us cosine squared x equals positive 1/4. And now we take the square root of both sides of the equation. Simplifying, we have cosine x equals plus or minus the square root of 1/4 is 1/2. So now we need to find all the angles that have a sine function value of 0 and a cosine function value of plus or minus 1/2 over the given interval. Let's first do this using reference triangles, and then we'll verify on the unit circle. To solve sine x equals 0, we can't use reference triangles. We need to remember that on the unit circle, the y-coordinate is equal to the sine function value, and y is 0 along the x-axis. So on the unit circle, the sine function value is 0 at the ordered pair 1, 0 on the positive x-axis, and the ordered pair negative 1, 0 along the negative x-axis. And therefore, one angle would be this angle here of 0 radians, and the second angle would be this angle here that measures 180 degrees, or pi radians. So two solutions are x equals 0 radians or x equals pi radians. Notice how we are using 0 radians, not 2 pi radians, because in the given interval, 0 is included and 2 pi is not included. And now let's find the angles that have a cosine function value of plus or minus 1/2. Ignoring the plus or minus for a moment, having a cosine function value of 1/2 should remind us of a 60-degree reference angle, or a 30, 60, 90 reference triangle shown here, where the cosine of 60 degrees, or 1/3 pi radians, is equal to the ratio of the adjacent side to the hypotenuse, which is 1/2. Which means to find all the angles over the interval from 0 to 2 pi radians that have a cosine function value of plus or minus 1/2, we just get a reference angle of 60 degrees in each of the 4 quadrants. So here's the reference angle in the first quadrant and the corresponding reference triangle. Here's the reference angle in the second quadrant, and again the corresponding reference triangle. Then in the third quadrant, and finally in the fourth quadrant. And now let's find the 4 angles. The angle in the first quadrant is 60 degrees, where 60 degrees is equal to 1/3 pi radians. Remember, to convert from degrees to radians, we multiply by pi divided by 180 degrees. In the second quadrant, we have this angle here, which is 180 degrees minus 60 degrees, which is 120 degrees. 120 degrees is equal to 2/3 pi radians. And then we have the angle in the third quadrant, which is this angle here, which is 180 degrees plus 60 degrees, which is 240 degrees. 240 degrees is equal to 4/3 pi radians. And then finally we have the angle in the fourth quadrant, which is this angle here, which is 360 degrees minus 60 degrees, which is 300 degrees. 300 degrees is equal to 5/3 pi radians. So we have a total of 6 solutions over the given interval. And again, let's verify this on the unit circle. Again, on the unit circle, x equals cosine theta, y equals sine theta. For sine x equals 0, we look for y coordinates of 0, which are here and here at 0 radians and pi radians. And then for cosine x equals plus or minus 1/2, we look for x coordinates of positive 1/2 or negative 1/2, which occur in each of the 4 quadrants. Here for positive 1/2, here for negative 1/2, here for negative 1/2, and here for positive 1/2. Notice how the angles are pi over 3 radians, or 1/3 pi radians, 2/3 pi radians, 4/3 pi radians, and 5/3 pi radians. I hope you found this helpful.